Hi all, very good morning. Guys, can you hear me? Hello.
Yeah, we can hear.
Yeah, okay. Thank you. Great. So, so MongoDB sessions, like we have some exposures. Today we'll jump to probability and statistics. I'll show you what we're going to cover today. Let people join. We'll start in 3 to 4 minutes.
Hi, Ashish.
Hi Dinesh, you were absent yesterday.
Yeah, I was.
Okay.
Yeah.
You went through the videos.
No, Ashish, actually, I didn't had time, so I have to go
Oh.
to, I have to go through it today.
Okay. No worries. That like everyone is like, I'm also having so many work in home which I need to finish. So
Yeah.
yeah.
So,
Mm.
that MongoDB session was yesterday completed, right?
It was
I know
completed.
it's silly to ask again. Yeah. Sure,
So
Ashish.
it is like this is not like completed. This is like the starting point initiated. So for you guys. So
Okay,
now
get it.
the more you are going to spend time, the more you are going to learn. Let
Yeah.
me share my screen and show that to you. So from here onwards till 2 to 3 sessions, not 3 sessions, 4 sessions actually, it will be on statistics and probability in mathematics. Okay, so let me like, can you see my screen, everyone?
It's loading.
Okay. No, not sure. Like sometimes happens with Zoom.
Yeah, now it's visible.
Visible? Okay.
Yeah.
Okay, so module 4, 5, 6, 7. Okay, 7 till 7 we have completed the things. Okay, because we are also going slow for this one. Now module 8 and module 9. Okay, module 8 and module 9, it will be based on 4 sessions we have. Okay, probability and statistics, and these are not like theoretical concepts. These are the concepts using which you are going to take some action on your project. That's why these modules got introduced also, because first of all, these are the conceptual things that you are going to get the questions from any interviewer if you're going for DS role specifically. And using this, I have all the materials for you. You need not to worry about it. I'll try my best to help you out with this conceptual things. So uh, like how many of you are not from mathematical background or not have exposure to probability or statistics before?
Obviously me.
Okay, so you don't have any exposure to probability before?
No, actually, for me, like when it comes to Max and me, like we were in different poles, so
Okay.
I didn't had that much of exposure in Max. That's why.
Okay, no worries. Then what we'll do, I'll try to make it like some layman or those who have not those who have not exposed have no exposure to this probability and statistics. We'll go like that, so
Yeah.
that you will also not feel bored or something like, okay, we don't know these things. But yeah, it will be easiest. And but like conceptually you need to understand these things, because what I'm going
Okay.
to tell you, like at the end you have to develop a model. If you consider suppose last session of your this course, you have to develop a model which will help you to solve some real world business problems. That is your aim ultimately at the end, that you will know the things so that you can help out in the industry by giving time and getting money. That's to
Hmm.
be honest, right? But if you understand what the model is doing at the end, it is going to predict one probability score. So if I'll give you an overall point of view, suppose you are developing one model which will identify fraudulent transaction based on users banking data or historical data of users. Okay, based on those historical data, you are going to develop a model which will tell whatever transaction is happening, those are fraudulent or not. Okay, this is called fraud detection, one of the famous problem in DS industry. Now what is happening, once you develop the model, it is not going to tell you fraudulent or not fraudulent, it is going to tell you both, but both should be associated with a probability or possibility value. Like suppose if it is fraudulent, then the score is 0.8, and for non-fraudulent it is 0.2. That's what it will predict. Now based on this score and prediction, you have to choose, okay, fraudulent or not. Okay, that means a possibility or probability score going to associated with your prediction. So that's why this probability and statistics also very important in this case. Those parts which are important for your model building, that you're going to cover. Okay, nothing deeper or nothing more than that. So let me where is my
And Ashish, you said that we'll get a project, right? So when we will be getting that?
I think in this, after this week or during this week.
Okay, okay.
I was also discussing with the technical team yesterday. Someone called me, I think Santosh, yeah. So he called me. We are discussing about the projects that is being given to the batches. So we're discussing about the the quality of the project and if anything can be implemented. So I suggested few things also in future. I'm not sure whether this YouTube scapping you are going to get or a new one.
Okay, okay.
Yeah, but definitely you are going to get a process. That's a mandatory process here in Ruby, where you will you will get a project to do. I have suggested to do one project on Chat GPT API implementation, because that is a hot topic I can see from my projects. Lots of clients are switching or wants to implement Chat GPT in their workplace. So I suggested to give one project in there. Probability and theorem. Okay.
But ChatGPT APIs, are they free? But I think we have to pay for them.
For GPT-4, it is paid.
Okay.
GPT-4. But like the normal one that we are using, everyone is using. I think that I have also not exposed till now because I am still working on that project. But yeah, you can explore that, the free versions.
So yeah, so we are using ChatGPT API for a product of ours. So there we had to pay for it. So that's why I was like, okay, do we have to pay the same here?
So
also?
are you using GPT-4 API or
yes,
normal?
Yeah, GPT-4, yes. We've been using.
So GPT-4 is a premium one and that has some additional features.
Yeah.
So
that has a connection with the internet. Like I think the version we were using has a data updated until 2021, but the GPT-4 has an internet connection also, so that it can give the real time and current data.
Not also GPT-4, now Google also, in the REST.
Yeah.
Bard
Google
is
Bard,
also,
yeah.
so Bard API, ChatGPT API, if you do one small project on this one, no, you will have more exposure towards the industry. Now as a DS guy, we need to start dominating the market because the industry is changing rapidly. So many things are getting, even if 5 months you will go back and how people are integrating, now this is completely changed. So there is no constant, like some basic things will be constant, but the process is getting changed. Okay. So let's without delay, let's start our probability. First of all, I told you the reason behind it, right? The probability score will be there. So that's why you need to understand how you are going to go for the probability. And here for specific DS problems, you like if you're going for some interview on a product based companies or Amazon or any service based or any kind of companies, from this area, you at least expect 3 to 4 questions anywhere you are going for a DS role. Okay, and we'll see a few problems are very conceptual. You have to rethink it. One day it will not come to you. You have to spend at least, you have to practice at least 10 to 20 problems. Then only you will get the mastery. We'll see. And now let's,
Actually,
before that,
yeah.
Mhm.
So all this MongoDB that we've been doing for a while. So how do you get a hang of it? Do we get a hang of it while doing projects like this, or is there any way to practice these?
So as like this depends on the scenario where we are working or not. If you're working and whatever you're learning, the first thing is you'll get all the benefit if you try to implement in your work environment with proper permission from the authorities. That is one thing, because that will give you the real experience, real world experience. And apart from that, you have these small projects where using MongoDB, SQL, all the coding knowledge, all the front end development knowledge, all these things you will combine and you will do a small project.
Okay. All right.
And you are going to get that, I think, in this few days. So let's see.
Yeah, sure. Thank you.
Okay. Now, how probability is getting calculated? It is based on counting. Simple thing, guys. Nothing complex here. Very simple. Counting. Suppose you are doing some events or you are doing some experiments. What is the all possible ways in which, or in like in a way you can do all the trials of your experiment? Count that. How many possible ways? So we are counting here. Okay, based on this counting, we are going to calculate the probability. Okay, for example, total outcomes of an experiment can be considered as counting, whereas using this counting, calculate probability of a specific event. For example, rolling a dice, image classification, etc., etc., etc. Now let's consider this rolling a dice problem. Very famous and basic example when we're starting mathematics. This example is there. This one, rolling a dice and a card, playing card. From there also you'll get few questions. So rolling a dice is, if it is the experiment, what is the outcome? To get 1, 2, 3. If I roll a dice, I'll get outcome 1, 2, either 1 or 2 or 3, like that. So when I count this, how many outcomes are there? Total, how many outcomes? Possible outcomes? 6.
6.
Any number from 1 to 6 you can get. So here what we are doing, we're counting. And based on this counting, we're calculating the probability. What is the probability of getting 1 if I roll a dice? So the formula is what? Number of possible events divided by total number of events. So how many ways I'll get 1? Only one way. And how many total possible outcomes are there? 6. So the probability of getting 1 here, if I roll a dice, is 1 by 6. This simple. And this is this part, like mathematics part is done here. This is what the mathematics is. You have to count the all total possible events. You have to count how many events you are going to get as per your requirement. Then you divide it. That is the probability. Simple. Now let's try to understand.
So Ashish, like, is this a usual formula that we will use for probability, right?
Correct.
You said
Correct.
correct. Can you please repeat that once again?
Yeah. So these are the elaboration of this, what I said.
Yeah,
Okay?
like total.
Basic.
You said some formula,
so
right?
with
that
example,
I can take a note.
I'm going to elaborate with example so that it will be easier for you to understand.
Sure.
Now, what I said, total experimentation. If I'll roll a dice, okay. Thing in this case. So if you see this total number of possible events that we are counting, 1 or 2 or 3 or till 6, that is called your sample space. The total possible outcomes for everything. So we are going to use this terminology from now onwards. If I'll ask you what is the sample space, you have to understand the total possible outcomes. Now, if I roll a dice here, what is the total possible outcomes? This is correct. Roll a single dice. Now, what is event? Event is something you are going to get from here or as per your requirement. Now, suppose a specific example. Suppose you are rolling a dice and flipping a coin. Simultaneously, you are doing it. Rolling a dice and flipping a coin. Now sample space means what? All possible outcomes, as I said, right? So here, what is sample space? This is the sample space. Can you think? Are you getting why this is sample space? Because we are doing both the actions simultaneously, rolling a dice, also flipping a coin. Then what are the possible outcomes here? Either one will come in dice, where in the coin head will come, or one will come in the dice and tail will come. This is with each number in dice. There is two possible outcomes. Similarly, when 2 will come, then head will come. Are you getting what I am saying here? When 2 will come in the dice, head can come. If 2 will come in the dice, tail can come. Like this, we have for every number, what we have? 2 possibilities. And how many number we have in the dice? 6. So how many possible events here? Can you see how many possible events here? So if I say calculate the event,
12 possibilities.
Right? So 12 possible events here. Now this is my sample space. So now Dinesh, you got some understanding on this one with this example?
Yeah, Ashish.
Okay. Now
Yeah,
here, what is the event? Event means that will be specific to your requirement. What is my requirement? An event might be the outcome of rolling an even number of the dice. This is my event. Try to understand it. So if this is my sample space, I want to calculate the probability of getting an even number on the dice when I am rolling a dice, also flipping a coin. This is my requirement. I want to know the probability of what? Getting an even number on the dice. So how many ways that is possible? Can you see? This is the way where even number you are coming in the dice, 2, 4, 4, 6. These are the even numbers. And with each number, there is a possibility of head and tail. So my event, as per my requirement, rolling an even number in the dice. How many are the possible? 6. Agree? Any other thinking apart from this? Now, if I want to calculate the probability, simple math I told, right? Total event outcomes divided by sample space outcomes. So the probability of getting an even number is how much? 6 by
6 by 12.
6 by 12. So
1
what
by
is
2.
50%? So that is also making sense, right? Three numbers are even, 3 numbers are odd in the dice. So there is a 50% chance that you are going to get what? An even number. And this is how you calculate the probability. The event divided by total sample space. Any questions till now? Okay. So simple, guys, simple, nothing complex, or like I was also fearing probability, but we are not going that deep. So here we have some basic things only. Now there are some, axioms. That means accepted truth that you have to keep in your mind while dealing with probability always. Like sun rises in east, like that kind of stuff. Okay, so accepted truth everywhere. Now what are the accepted truth about probability? So let me first define you. These axioms of probability are set of rules that define the probability of an event occurring. This axiom provides a foundation for the mathematical theory of probability, which is used to model and analyze uncertain events. For example, what is the first rule? Probability of an event is always between 0 and 1, 0 to 1. It will be always 0 to 1. So whenever you ask for someone about the probability, it will be what? 0 to 1, a number between 0 to 1. And mathematically also you can prove this one when you divide something with the total count. That's what we are doing here in the up also, right? 6 by 12. So when you divide something with its maximum value, the value will vary between 0 to 1. Mathematical also it's making sense. So it is not wrong to say that whenever I'm going to calculate the probability, I am going to divide it with the total or the maximum outcomes. So always this will be between 0 to 1. This is first rule.
Sir, like we got 6, right? So it doesn't come between 0 and 1.
Sorry, what we got?
Like we earlier calculated the this thing that we got 612 divided by 6 when we were trying to roll a dice.
So
6
what is
divided
the
by 12, that means 1 by 2. It's
1 by 2.
0.5.
So after dividing, I am talking, not like the outcome. So outcomes is like counting. Counting will be always more than 1, isn't it?
Yes.
1 or more than 1. But what is probability formula? Total event divided by total possible outcomes. That is probability. And that factor is between 0 to 1, not the counting part. A good question. So even if you have small doubt also, you can ask, guys, not a problem. Even if it is a silly doubt. Because fundamentally will get strong. And if you, yeah.
Ashish, sorry to interrupt you. Can you please repeat this once again?
Yes. So this one.
No. This axiom,
this,
like that
okay.
I'm clear.
Okay. See what we did here. Can you try to explain in your own words? It is going to benefit you. Yeah.
So like on about to that, like we were seeing all the sample events, like the all possible outcomes that we can get from our operation that we were doing. So then we were specifically giving an event so that we can get a even numbers in a even numbers in a sample space. So with that we were getting 6 outcomes.
6 outcomes and total outcomes are 12.
Yeah.
Right. So what we did to get the probability, the 6 divided by 12.
Yeah.
That we did. So
yeah.
When you divide something with its maximum possible values, that will be always between 0 to 1.
Okay. 6.
With its maximum values, that is we have. So that's why we got what? 0.5, which is 0.0 to 1, isn't it?
Yeah. So the 6 divided by 12, right? 6
divided 12. The probability is 0.5. If we'll convert this to percentage, what is percentage? 50%. That means when I say a probability is 0.01, then what is the percentage I'm talking about? So suppose one event is going to happen with a probability score 0.01. That means what is the percentage of probability? 1%.
Yeah.
So if I say the probability score associated with this event is 0.01, that means there is 1% chance that that event is going to happen.
Okay. 1% chance.
Yes, in percentage I'm saying. But probability score will be always between 0 to 1.
Okay.
Okay, so this is what the first axiom is saying. Okay, what is the second accepted truth? The second axiom is that the probability of the entire sample space equals 1. The probability of an event occurring is 1 minus that event probability. What does that mean? If the probability of raining tomorrow is 0.3, that means what? 30% chance there is going to rain tomorrow. Then the probability of not raining will be 1 minus 0.3, that is 0.7. That is also making sense, right? If something is going to happen with this much of score, not going to happen is 1 minus that much of score. Now suppose there is 30% chance that rain is going to happen, or there is going to rain tomorrow. That means I am telling indirectly there is 70% chance there is no rain tomorrow. Okay.
Sir, is there any condition like we need to take first positive prediction and then for the next we need to take negative prediction? Is that like that?
When you say negative prediction, what does that mean? Like you are going to say
like first we will consider any condition as a positive. In second scenario, we will consider anything as a negative as of first. Is something like that?
See, that's why I said it is always between 0 to 1. So there is no possibility to get a negative sign here. So 0 to 1, like it will be the probability score always for any kind of event, it will be between 0 to 1. Okay, not like negative number, always between 0 to 1. But yeah, negative will come, but I don't want to confuse here right now, or you will get confused. Okay, but think about it, always between 0 to 1. So I can't say the probability of raining tomorrow is minus 0.3. I can't say that.
I didn't
Excuse me, sir. Excuse me, sir. The probability of raining tomorrow 0.3 you have given here. Now we have seen the number you have given. How do we know the probability of the 0.3 is the possibility?
Okay. Yeah. So you will see like how to calculate. This is just for example. Suppose whatever method to find. So you are asking like what is the method to find this 0.3, right? Yeah. So that one is a separate thing. Just think of like that. We somehow got the probability 0.3. How we got that is a different thing that we're going to see eventually.
Okay.
As
Ashish,
of now-
I have the following same question, similar kind of question. So here we have the 0.3 as a first come first serve. So this is how it works, or like the higher chance of the if you see that 0.7 70%, that has the higher percentage. So which one should we consider the first one? Either it's 0.3 or 0.7.
So this one is a valid question here. So 0.3 means rain, 0.7 means no rain. That is confirmed here, right? Now if you see here, what is the highest possible chances of the event?
No rain.
0.7, no rain. So what you're going to say? That tomorrow is not going to rain. Okay, so this is the same example I've given to fraudulent and non-fraudulent. So suppose there is a chance, 30% chance the transaction is fraudulent, 30% chance. That means what? 70% chance the transaction is non-fraudulent. Then in this case, what I'm going to predict, fraudulent or non-fraudulent?
Not fraudulent.
Yeah, because the higher possibility is associated with that event, isn't it?
Sir, is this concept similar to hypothesis or it's different, sir?
This is not hypothesis. Hypothesis is something different. This is the generic rule. Everywhere it will find the same thing, accepted truth.
Okay, sir.
Hypothesis means we are just imagining something, and based on that theory we are proving something, right? That is hypothesis. We are not sure about that, but this is actually mathematical rule. Okay, and in mathematics also you can prove that by giving this example, 6 divided by 12. So when you divide something with the total possibility count, that is this number, the division number will be between 0 to 1 always. Okay, so yeah, so no worries guys. Okay, you will, the real part has not come yet. This is just starting. Okay. Don't worry, when you see some problems, how the problems, conditional probability, the other theorems we are going to see, there is the actual part. It is just the starting. Okay, don't worry, and don't try to stress it out in here, because we have other things also down, we'll see. Okay, now let me go, like let's go through the accepted truth first, because we have to implement these things in our real life issues. Okay, and yeah, so second point is I think clear. Third point, what is the third point? If two events are mutually exclusive, meaning that they cannot both occur at the same time, then the probability of either event occurring is the sum of their individual probabilities. For example, you have a jar with 5 red marbles and 4 blue marbles, the famous marble problem. Since college days I'm seeing this examples. The probability of drawing a red marble is, so 5 red marble in a bag, 4 blue marble in the bag. Total how many marble, guys? 9. So the event space is here. Total is 9. So whatever you are going to calculate, you have to, if you are going to calculate the probability, you have to divide this with 9, because that is my event space. Now what is the event? Drawing a red marble, that is my event. Now, in how many possible ways I can draw a red marble from this Nile marble? 5 possible ways, because there are 5 red marbles. So the probability of drawing a red marble from a bag, which bag contains 5 red, 4 blue. What is the probability? 5 by 9. The probability drawing a blue marble is what? 4 by 9, because 4 blue marbles are there. So in how many possible ways you can draw a blue marble? In 4 possible ways. So the probability of drawing a blue marble is 4 by 9. Now here you need to understand the mutually exclusive concept. That means what? Both the event can't occur at the same time. So if your event is to draw a red marble, at the same time you can't go for blue marble, right? Because your event is to draw the red marble. So these are mutually exclusive and they are not happening at the same time. We are specifying this condition initially. They are not overlapping with each other while doing it. Now, if this is the case, where the events are not overlapping or not occurring at the same time, then what is the probability? What is the question here? The probability of drawing either a red or blue marble is what? Now, the probability of drawing either a red or blue marble means probability of drawing either red plus probability of drawing either blue. That means what? 5 by 9 for red marble plus 4 by 9 for blue marble. Now, what is the score here? So if I'll twist this question a bit, I will introduce. Can you tell me now? Same question I'm going to asking here. I'm going to change some modification in the event space. What I'm going to do? I'll introduce another 5 green marble. But the question is remains same. The probability of drawing either a red or blue marble is how much if I'll introduce another 5 green marble in this scenario in the bag?
So it will be 14.
4 by 14.
Anyhow, the outcome will be 1 because we are going to draw only 1 marble.
So if I'll introduce 5 green marble, what is my event space here? Total count of event space?
5 by
14.
14.
Total space, sample space will be 14.
Yeah, sorry, sample space will be 14. So drawing red marble will be 5 by 14.
Another 5, yes, 5 by 14.
And drawing blue marble will be 4 by 14. Right?
Yes.
Now the probability of drawing either a red or blue marble will be how much?
Again 1.
No, that I think that will be
Oh, 2. No, 1 will be.
9 by 14, right?
Right. 4 by 14 plus 5 by 14.
Okay.
I have not. If I'll add probability of drawing either a red marble or a blue marble or a green marble, then you can write 5 by 14 plus 4 by 14 plus 5 by 14 again. And that will be 1 because I am combining all the event. But if I'm only looking for the probability of drawing either red or blue, and I have total 14 marbles in my bag, 3 colors. Making sense, guys, right? How this is getting calculated?
Yeah.
Okay, if it is making sense, I'm really happy for you guys. Right. Now, another rule. Okay, these things are very important because this concept, I'll make you understand. If you're trying to understand when exclusive events, and in a layman term, you are using this or, either this or this, the probability of this or this or this. Okay, try to keep these words in your mind: mutually exclusive and this or. Okay, we are adding the probability just for simplicity to make you and keep in your mind. Now there is another thing is called that independent event. Independent event means totally different event. I'm not drawing the marbles from the bag. What I'm doing, I'm drawing the marbles, that is one event. I am now flipping the coin, that is another event. Independent event. What does that mean? That occurrence of one event does not affect the probability of other event.
So independent means like two different events, right?
Two different events, correct. And then if you calculate the total probability, here you calculate the total probability, individual events probability is getting added, right? But here if you calculate total probability, if those are independent event, then those probability will be multiplied. So mutually exclusive and or, that is add. Okay, independent and using here we are using or, right? Here you are using and, you can see here and. When independent and is there, you have to multiply. This is just to make you familiarize. That is no certain rules like this, but just to how you can keep in mind. Now if the probability of flipping head of a coin is 1/2, now how it is 1/2? Probability of getting head.
Because head and tail, there is a two
possible
even space, yeah.
That is sample space.
Yeah.
Sample space is the total, which is denominator. Okay, and getting head means 1, right? Out of head and tail, you are choosing head. That is 50% chance you will get head and 50% chance you will get tail. That is one event. Okay, probability of drawing ace of cards from a deck of cards. Now this you need to tell me, because I know you don't play poker, but you have some understanding, right? Ace of spade. What is ace of spade? Can you tell me the color of ace of spade?
Spade means black color, right?
Let's see, quickly verify. We have
Black
image search option, right? So please bear with me, my system is very slow here. So this one, guys, see this is ace of spade. Now what is the probability of picking a ace of spades from a whole card, from the deck of card? Now how many cards?
1 out of sample space, total cards.
52. So from each color we have 13 cards. We have 4 colors, right? So we have total how many cards? 52 cards. And from the 52 card, I am asking the probability of choosing this card. If this is one card is there, the probability is 1 by total card. Then this is what? 1 by 52. Now my question is, what is the probability of flipping a coin head and drawing a ace of spade? Then what I'll tell? This probability into this probability. So probability of flipping a head and drawing a ace of spade is 1 by 104. You're getting? So these are the basic rules that you need to keep in mind while go for the probability. This is just the starter. Okay, starter part. Using this accepted truth, we are going to explore the probability theories and theorems. Now a practice question set for you guys. I am expecting everyone to do this, because if you understood, I want to calculate the probability of getting a jack or a spade from the deck of cards. Tell me now. Just a quick question to practice your thinking.
From out of total cards, 52 cards. No?
Correct. Probability of getting a jack or a spade.
It will be like 1 by 52 plus spade is 13 by 52.
I am going to request you guys to please rethink your answers. Please try to find out what is jack, how many jacks are there in the whole card.
So 4 jacks.
It's a
4 by
jack.
52.
Right.
4 by 52 and plus spade means 13 by 13 or 12.
Okay, but again, I'll request you guys to rethink it. There is one catch here, because
yes, jack of spade is calculated in a jack.
Right. So let me Good. So that means you cracked it. Let's give some others also. Let's give some time. Just 1 minute, guys. Think about it. How to calculate the probability? I think C has already explained this answer. You just need to rethink and summarize this. Let me also do with you. Probability of getting a jack. How many jacks are there? Each
4
color
by
contains
52.
a jack. So 4 by 52 is the probability of getting a jack.
Yeah.
What is the next event? Getting a spade.
Yeah.
Spade means what? That black color heart, right?
Yeah.
1
So,
by 52.
13.
so getting a spade. How many spade cards are there?
13.
13.
13, right? So 13 by 52. This is the probability of getting getting a jack, and this is the probability of getting a spade.
Mhm.
Now you are calculating something here twice. What is that? The jack
Jack
is
of
also
spades.
present in the jack is
Spade.
also present in spade also, isn't it? So we are calculating that probability, but that particular spade of jack probability twice, here also, isn't it?
Yeah.
Do you agree with me? So what we need to do? We have to, so what is the formula? So these are what? These are not affecting, right? If you are, so that's why we are subtracting that jack part, because we want this is not affect this. If you are doing this one and this one, this should not affect each other. And total probability is this probability plus this probability minus the probability that we calculated twice, here also, here also. So what is the answer now?
Like, how come the probability will be one, Ashish? Because in here and we have two course of events now. So from 4 and 13, so we were calculating it twice, right? So we're supposed to give 2 on there, right?
But if we'll subtract the 2 1, then that is not going to consider at all. So duplicate only you need to remove. You have how many duplicates?
1 duplicate.
Yeah, that's what we are removing, right? So we'll subtract 2 by 52. The probability of getting jack of spade is totally we are removing. So we added here. So 1 by 52 we added. 1 by 52 is here. Also 1 by same 1 by 52 is here.
Okay.
So that's why we're subtracting one of this.
Okay. So however, in a spade, the jack is going to be there. So because of that, like we were removing jack out of it, and in the spade, however,
Correct.
we're going to get it.
Correct. So the answer is what? 16 by 52. So if someone will ask me the probability of getting a jack or a spade, this is 16 by 52. Okay, simple guys, simple. If you try to think with a clear mind, no, this is very easy. And here now the fun part comes. Okay, the theorems. I'm not sure. I've never taught actually this theoretical concept to anyone previously, to be honest with you. But yeah, I feel the same. Like when we have some theoretical things, so I tried my best to make it interactive in terms of codes and visualize graphs and all, so that you won't think like, okay, this is a theoretical thing. But yeah, these are the things from where you'll get theoretical questions for sure. Okay. Now there is 2 theorems and very important, and these are the essence of the DS. Okay, this is called total probability theorem and the Bayes theorem. These 2. Now theorem comes. Now we'll apply whatever logic we understood from above using in this theorem. Okay. Now let's understand what is total probability theorem with example. Okay. Now the total probability theorem is a fundamental rule in probability theory that allows one to calculate the probability of an event occurring by considering all possible outcomes. Along with this, their associated probability. It states that if a process can be broken down into smaller steps or events, and once you broke down to smaller events, the overall probability will be what? The sum of these small events that you created. This is what total probability theorem says. For example, this is the good example here to understand. Suppose there are 2 factories, okay? Factory A and factory B. that produces certain product. 2 factories you have. The quality of product can be classified as either good or defective. So every factory produces good product and defective product. Factory A produces 60% of good product and 40% of defective product. And factory B produces 80% of good product and 20% of defective products. Now this is your given scenario with conditions. And how many percentage or what is, now that means what here? If I say percentage, what I'm indirectly saying? The probability of getting good product from factory A is 0.6. The probability of getting defective product from factory A is 0.4. Similar case in here also. What is this? 0.8. This is 0.2. Making sense? This question understood? Now let's say you randomly select a product from one of the factories. You randomly choose any factory you choose and you draw one product. What is the product? What is the probability that the product is going to be defective? This is your question. And we are going to solve this using total probability theorem. Total probability theorem is saying what to us? Break the event into smaller steps or events, then calculate their overall probability by summing them up. So before we jump into the explanation, can you please go through this question and try to understand what is data given and what you are going to solve?
Going to use only the defective products data.
Correct. So what is the probability that the product is defective if I come randomly and choose any product from both the factories? Now this is
So
bigger
it
thing.
will be like 0.4 plus 0.2 by 6.6.
Okay. No worries. You tried that is very good thing that you are trying. So, but we are going to solve it using total probability theorem. And this is going to make sense now, more sense now to you. Okay. Now let's say you randomly select a product from the factory. Okay. So you can break down this scenario of choosing from different factory. What is event 1, event 2? Event 1 is if you are randomly selected, event 1, let's suppose you are selecting from factory A. Event 2 is what? You are selecting from factory B. My final question is what? Probability of that the product is defective if I choose randomly from both the factories. Now here what I am doing according to total probability theorem, I am breaking this step, the whole step into 2 smaller steps. That is, if I am going to select randomly, let the first event is I am going to select from factory A. Let the second event will be choosing from factory B. Okay, I broke down into smaller steps here to calculate what? To calculate this question. Till now, making sense? Now, to calculate the probability of individual event, what we are calculating? Selecting a defective product. We are calculating the probability of what? Selecting a defective product. Now we'll calculate event wise. First we calculate for event 1, then we'll calculate for event 2, then at last we'll add the total probability, and that is the answer to this question. Now probability of selecting a defective product from factory A. What is the probability of selecting a defective product from factory A? Here it is already given to you.
0.4.
0.4. That is the probability already given to you. But here you have to multiply the probability of choosing factory A. Please think about it. Probability of
50% maybe.
Correct. So probability of choosing either of the factory is what? 50%. That is what? 5.5. So first you
1/2.
choose. Sorry.
1/2.
Correct. Yeah, correct. 0.5, 1/2 into probability of choosing a defective product from that particular factory, which is given, what is that? 40%, 0.4. Now, why we are multiplying this probability? Choosing, if you recollect our what independent event, here we are doing what? Choosing one factory out of two factory, and apart from that, and choosing a product from factory A. Two things we are doing. That's why it is what? Probability of selecting a factory into the probability of defective product inside that particular factory. That is probability for event 1. So this probability of selecting factory A into probability of selecting defective product from factory A, this is what? 0.5 into 0.4. That is probability for event 1.
Ashish, like that 0.4 I can get, like how come that 0.5
0.5,
selecting?
how come? Because see, mark my sentence, what I'm saying here.
Mhm.
Select one of the factory, that is one event, and after selecting, and you select a defective product. Now what is the total probability?
Okay.
This one, this rule.
Okay, so I have two course of events now.
Two course of events, that is
Yeah.
independent event, but both need to be happen simultaneous, right? The total
Yeah,
probability of
yeah.
calculating. Select a factory and draw a defective product. Okay, so that's why
Okay.
both the probabilities getting what? Multiplied. For what? For event 1 specifically.
Okay,
So
so
this-
like probability of selecting factory A into probability of selecting defective B, right? So
defective
selecting
from factory A.
yeah. So like I can totally get that, like 0.4, that is fine, because in 100% like we were getting 0.4, but still that probability of selecting A, like with what we were dividing it.
Okay, very good question. Okay, please ask this type of questions. Selecting factory A, probability of selecting factory A. Forget about all questions. Now only one question you have. What is the probability of selecting factory A from the two factories? So tell me the sample.
It's like a coin or head of
Coin, flipping the coin.
Yeah.
What is the probability of getting head? 1/2.
1/2.
Because
Yeah.
the total possible outcome is head and tail, right? And you are
Yeah.
choosing head. So this same case here. Selecting a factory from two
Yeah.
factories. What is the probability? 1/2.
Yeah.
And after you choose the factory, and then the probability of selecting a defective product.
Okay.
Getting it now?
Yeah.
Got something in the chat. Okay, Divya, I got your point. Well, once we finish this, we'll do that. Okay.
Okay.
Okay. So this is what? For event 1. Okay. Similarly, you can calculate for event 2. Probability of selecting factory B is also 0.5. And probability of getting the defective product from factory B, what is that? It is given, right? 80% good, 20% defective. So 0.2. So what is the probability of getting for event 2? That is 0.5 again into 0.2. Now, what is the total probability of these two events combined? This probability plus this probability. That means what? 0.5 into 0.4 plus 0.5 into 0.2. So what is the answer? 30. 0.3 we are getting. That means what? Therefore, there is a 30% chance if you randomly choose one defective product from A and B company, you will get defective product. There is a 30% chance. That means what? If you randomly choose a product from these two factory, 70% chance is like you are going to a good product. 30% chance that you are going to get a bad product or defective product. So this is a simple example of what? Which theorem we are discussing, guys?
Total probability.
Total probability, right? Okay, because that was our first total probability. So whenever I say total probability, break into small events, calculate the small events probability individually, then sum them up. That will be your total probability of some event. Okay, now let's jump to Bayes theorem, guys. Okay, now this is where the fun part begins, and this is where you are going to, get your head a bit, So here, Bayes theorem is the, actually, if you see, it is the backbone of your DS models. If you are considering statistics and probability into picture, this Bayes theorem, because based on this theorem, there are some machine learning models also called naive Bayes model. Okay, that's why this theorem is, and from here only you will get, you expect two type of questions. I have a list of the questions with answers, the PDF files with me, which I already shared with you in the G Drive. I'll try to solve one question from that questions, and you spend more time, because there is no shortcut here. If you don't understand in one go, you have to keep trying for this one. Okay, so let's try, before that, let's try to understand what is Bayes theorem. Now, what is the difference between the total probability and Bayes theorem is that Bayes theorem works with an evidence. What I said, my evidence means Bayes theorem is a mathematical formula that allows us to calculate the probability of an event occurring given certain evidence. Okay, so the scientists, the statistician and the theologian, actually he developed this concept in 18th century, and the formula for that is PA by B. This is not by, okay, A given B. This is how you need to read it. So when I say PA by B, okay, I need to use the pen here, 1 minute. So here, please keep your mind here, guys. So this means what? Probability of A given B. So B is here the evidence. This is called, also you are called conditional probabilities. What is the condition here? B. That means B has already happened. For example, you are calculating the probability of rain given there are clouds in the sky. Now, what is the condition here? Clouds in the sky. Now, probability of calculating rain and probability of calculating rain given clouds in the sky, these are two different things. Do you agree with me?
Yes, sir.
Because based on one condition, we are calculating the probability. This is called conditional probability, which we are going to use inside Bayes theorem. And according to the formula, when you are calculating something called probability of A given B equal to probability of B given A. This is not too, don't get confused, guys. I know this is initially this is confusing, but these two are totally different things and totally different meaning also. Probability of A given B equal to probability of B given A into probability of A divided by probability of B. This is the Bayes formula. Okay, and here I actually forgot to mention in the notes, but I wanted to show you all. Just a minute. Before that, let's just try to understand this terminology. So what is probability of A given B? Is the probability of event A occurring given that B is true. That means B has already happened. There are already some clouds in the sky. By looking into that, you are predicting the probability of rain. That's what I'm saying here. So what is right side to this pipe symbol? that is what? The evidence, or that has already happened. Always think like this. And the left side to the pipe is the probability for which you are calculating the probability. So probability A pipe B means probability of A you are calculating given B has already happened. Making sense?
Yes, sir.
What is this? Base, prior, posterior. So what is this terms? The terminologies I forgot, you just keep in mind, or you can search like this, you'll get it. Now these things are called something called this left hand side, that is probability of A by A pipe B or A given B is called, the whole term is called posterior. Now why we need to keep this in mind? Because sometimes you get the question where they will say posterior is this much, prior is this much. So that time you need to understand what they are pointing out, or else you will get confused. So this left hand side term called posterior, probability of A comma A given B is posterior. Probability of B given A is called likelihood. Okay, probability of A is prior, probability of B is margin or marginalization, anything that you can use. So these terms you need to acquaint it. Like I just want you to correlate the terms with this. So this is called what? Again, this is called posterior. This is called
Likelihood.
This is called prior. And so try to find the pattern here, guys, right? A given B is B given A. Then whatever calculation you are doing for the event into that probability of A divided by what is right side to the pipe. Okay, and this is called posterior, this is called likelihood, this is called prior, this is called margin or marginalization, something, whatever term. Okay, now this is the mathematical.
Excuse me, in that formula, that A, we are, that left side A is we are going to find, B is already given, that a cloud like, that
Correct.
B of A, that here the B is the cloud already they given, that A part is.
Correct. So we have one example here. I have a beautiful example, just I saw you. Here you will understand here. Okay, no worries. With proper example, what these terms and left hand side and right hand side. So the point is here how you need to read it. Probability of B given A is true. Okay. So probability of B and pipe A means what? Probability of B given A is true.
A, we are going to find that thing is right. Then where should we get the A of B of A?
That also will be, you need to find from the question. It will, this data will be, so this is called likelihood. Likelihood will be given to you.
Okay, sir.
So once you, it's not started yet. Again, like we'll start. Once you understand this concept, no, the real question will start. Okay. Now, in other words, Bayes theorem allows one to calculate the probability of an event A based on the probability of another event B and the relationship between the two events. Okay. The total probability theorem is similar to Bayes theorem. That is that it also deals with calculating probabilities, but it is used in slightly different context. What is the context? Whereas Bayes theorem is used to update probability based on a new evidence. That is that pipe, right hand side to the pipe. But the total probability theorem is used to calculate overall probability of an event occurring by considering or by summing up the individual probabilities. Okay. For example, let's try to.
Ashish, can you please, go through these 2 points again?
Okay. You please read it out and try to understand.
Yeah. In other words, Bayes' theorem allows one to calculate a probability of event A occurs based on probability of another event B
That means
occurring.
what? Stop here. Let's try to understand.
Yeah,
That means what?
yeah.
That pipe right hand side to the pipe part
Yeah.
based on probability of another event B. Yeah, please. Yeah. And the relationship between the two events. It is often used in situations where there is some uncertainty or lack of complete information.
So like,
That means what? You are not sure whether rain is going to happen or not, but looking at the cloud in the sky, you are predicting the probability. That means based on some new evidence. Here, what is the evidence I'm talking about? Cloud. I am seeing cloud in the sky, so that's why I'm predicting, okay, maybe there is a chance, 30% chance. Like how 30% chance we are going to see next. But yeah, probability, some score based on the new evidence. But total probability theory is doing what? It is breaking into individual events. That suppose you want to calculate the probability of rain. Then according to total probability theorem, how you are going to solve? According to Bayes theorem, how you're going to solve? Can you think about it and answer me? Then I think these points will be these points make more sense to you. So try to calculate the probability of rain according to total probability theorem and try to do it with Bayes theorem. So in total probability theorem, what we do? We break into smaller events.
yeah, yeah.
So that's what these 2 points explanation is down here. Okay, with example. Probability of rain, let's consider. In total probability theorem, what you need to do, you have to see the probability of humidity. Here I am just calculating individual events. Probability of humidity, probability of temperature, probability of clouds. If humidity will be more, that means what? Higher chance of raining, isn't it? Temperature is cool. If temperature is low, higher chance of raining. Because it can indicate somewhere rain already started, you are getting cool breeze, cold breeze, right? And simultaneously you can see clouds and thunders and all. So these are the small events here. In like you are breaking or you are calculating the probability of rain based on these events that you are creating. Now, if we will add the probability of these things, it will give you the probability of the rain is going to occur. But this is as per what? Total probability theorem. Making sense?
Yes.
Okay. But same thing, if we'll calculate based on Bayes theorem. But in Bayes theorem, what is our basic requirement? We have to have a evidence. That is our requirement to use Bayes theorem. Now, how to solve this question using Bayes theorem? Let's see. Now here, let me read here. The total probability theorem would allow you to calculate the overall probability of rain occurring by considering all of the different factors that could influence the probability of rain, such as humidity, temperature, presence of cloud, okay, and summing the probability of each factor to get the total probability of rain. It is total probability theorem. Now, Bayes theorem, on the other hand, Bayes theorem would allow you to update your belief about the probability of rain occurring based on a new evidence or information, such as weather forecast that indicates a high probability of rain. There's a new evidence that you got. Based on that evidence, you are saying. Now here, the evidence I am going to use as I am going to predict.
Ashish, I'm sorry to interrupt you. Like, you know, I don't know why, like, I'm getting confused so much. Like,
it's not started. It just started, Dinesh.
Yeah. Like,
just started.
I don't know. Yeah, I don't know. Like, for the first time, like, I'm getting confused this much.
No.
Like,
It's like I can assure you, you are going to confuse a lot. It's not just started, guys.
So like
yeah, tell
with
me
the
your
with the
doubt.
yeah with the total probability you're saying, right? Like with the total probability also we can able to calculate the rain kind of stuff, right? So the total probability, if you're going to calculate, means like if in the factory thing that was different, okay, so we're going to select from factory A, and then we're gonna select the defective product, so that we have a two course of events, like two different course of events in a same factory. So likewise, like in here we don't have that kind of two course of events, right? Like here we only have humidity, temperature, and
Three
clouds,
course
right?
of
So
events we have here. There are
yeah,
two,
so
here we have three.
mhm.
What is the three event?
Humidity, temperature, and presence of sky.
Yeah, probability of getting humidity, probability of getting higher temperature, probability
yeah.
of getting more
Present,
number of clouds. These
yeah.
are the, so there are two events, here three events. Now I don't have the exact probability with you, that's why I can't correlate this with the factory example and show you the summation. But yeah,
Okay.
you can think like this, three events are here, and if you have
So
yeah.
for example, like if I'm having a humidity of 0.2 and then the temperature of 0.5 and then the presence of cloud is 0.3, so if I correlate all this, then I can get a
clear
probability.
picture. So
Okay.
that depends which factor you are calculating, probability of temperature high or low, that you are calculating. That also you need to specify, right? Probability of getting temperature high and probability of getting temperature low. Which
Okay, so
factor decides rain?
likewise we did in the
Correct.
factory thing. So I have to look for the temperature high into temperature low or what?
Correct. So the point is here, like this is not the, to be honest with you, this is not the exact example, but
Okay.
you can think in this way. If you are going to predict the rain, which I'm not sure, I have not done yet in my real life, but
Yeah,
just
like
for
with
example,
if we were doing it with the total probability, how we'll do it?
how we'll do it. Yeah, this is the way. Just to understand this, not like a specific example here, but yeah.
Okay.
So divide into smaller events, then calculate their individual probability, then sum them up. This is what total probability theorem. Okay. Now in Bayes theorem, this is based on some evidence. Okay. What is the evidence I am going to calculate here? At the starting of the day, I am looking for the evidence. Okay. I'm going to predict whether today today will rain or not. What is the evidence? I am looking at the morning that there is cloud in the sunrise or not. That is my evidence. If I see cloud during the sunrise, there is a possibility that more possibility that rain is going to happen. Okay, this is my evidence. Clouds at sunrise. That is what? B in the formula. This is the B. And what is A here? Probability of rain. So what we are calculating using Bayes theorem here. If you see probability of A comma B, right? Then that is the formula there. What is A here in this scenario? It is rain. What is B in the scenario? Cloud during sunrise. So I'm going to use CR and R. R for rain, CR for cloud in sunrise. I think CSR, not CSK. Okay, guys, CSR. CSR means what? Cloud during sunrise. This is my B. Now, if you are going to solve this kind of problem, now what is the question here? Please tell me what is the probability of rain given cloud during sunrise? This is my question. But what if I'll put this into the formula? What do I need to write, guys? Tell me. Probably this is probability of A given B, right? What is the formula?
Yeah.
Probability of B given A. What I need to write?
Yeah.
Probability of
CSR
given R into
probability of rain.
R.
Right. So here into probability of A, probability of R, divided by probability of B, probability of
CSR.
And I was like telling this to you, this things where you are going to get confused. So here only possible thing, even if you are not going to believe, I have, when I started this one, I confused so much, I did so much stress. I searched in Google how to crack this kind of question. The answer Google gave me is like practice, practice, and practice. That's what I got. So the more questions you are going to practice with this concept, the concept is same, nothing more than this. This is all about this. But here, using this formula, you have to understand which data is given to you, because there you are going to get confused. Probability of this given that, or probability that given
Use
this.
more of understanding, sir.
Correct, exactly. So understanding. So don't worry, I have also questions with answers, okay, like 10 to 20 questions with answer for you, so that you can go through that and try to understand. We'll see. Now let's try to implement this particular condition here with this formula, and let's see, this data is given. This data is given. Can you tell me what data is given by reading it out? It rains 25% of all days. So in real life scenario, this sentence will be given to you. It rains 25% of all days. What insight you need to draw from here? That means P of R is given. That is what? 0.25.
So like this 25% of rain was already given to us. Like
Given,
this
the
fact
data
was
is already
given.
given to you. Yeah.
Okay.
So based on this given data, what you are calculating? Probability of rain given
Yeah.
CSR.
CSR. Yeah.
This you need to calculate. Where
Mhm.
what data is given? It rains 25% of days. That means probability of rain. It is cloudy at sunrise only 50% of the days. Try to understand this one. And here the logical part starts from here. It is cloudy at sunrise only 50% of days. What does that mean? Probability of CSR
CSR.
is given to you. That is what?
0.15.
So it is direct probability. We should not find from this like out of 15% means by 365 days like that.
No, don't go deep into that. Just try to think what they are given. So if you let's not consider this days factor, months factor, that will be more complex. Let's make it simple. This giving that usually there is a 50% chance, when 50% chance in a year, you can consider in a year, where the clouds will be at sunrise. That means if you consider 100 days, last 100 days data from the what the department will deals with weather and all, you got the data from them. Past 100 days they analyzed, and they told you out of 100 days, 15 days we have seen clouds at sunrise. Whether it rained or not, that information they didn't give. They told you out of 100 days, 15 days we have seen, or our department seen, clouds are during sunrise. Now making sense? And from our data, we discovered that there were clouds at sunrise on 50% of the days it rained. Now this is the vital point here, guys. There were clouds at sunrise on 50% of the days it rained. That means what it is saying?
So the rainy days had 50% of sunrise.
That means it is saying probability of CSR given rain. Try to understand. Clouds at sunrise, on 50% days it rained. That means it rained is already happened, which is right side to this pipe. It rained. That means rained. Probability of clouds at sunrise is 50% when the evidence is rained. That means probability of cloud during sunrise given rain already happened. So this data is now 0.5. So Dinesh, I would like to know your thinking here.
Yeah, like yeah, now with the example I can get it. Like if you want to, understand me that, like now I can get it. Like the probability of rain means okay, that is fine, 25, and the cloudy thing, okay, that is 0.15, and
Great.
the
Great.
CSR BR, that is fine. But when it comes to the understanding only, I'm feeling like, for the first time, I'm feeling that much
Uh,
sleepy. I'm just, like, like straining my eyes. Don't close, don't close, don't close like that. I really don't know. Like
okay.
whenever the word max, I'm feeling,
Uh,
I'll automatically,
Now,
my system getting shut down.
but the other thing happens, like once you start, the point is here, if you're switching to this field, no, you have to
Hmm.
develop immense patience here. You have to
Okay.
wait for the right time to understand. If you
Yeah,
in
yeah.
hurry, no, then
Yeah,
you will stressed out. So the
yeah,
point
like
is, huh?
actually the problem is I have a word, like I have allergy with the word max. That's the only problem.
Yeah, no risk, no risk. That's why I tried to make it, in a
Yeah, yeah.
visually ways, because we
Mm-hmm.
used to read mathematics books that is like only theoretical. Like you
Yeah,
can imagine how we used to get
yeah,
of
yeah,
those things. So here you have at least some figures to explain this terms, and we'll see
yeah.
also when we'll go to
Sure,
statistic
sure,
part,
sure.
we'll see with code also, because that
Yeah.
time implementing mathematics in a code is a very big thing. As per me, I'm
Okay.
not sure about you guys. You have to tell me your experience. But yeah, the point is here, this, the right hand side I have given this data, right? This is not going to given you, okay? In the question, this will they tell, okay, this sentences, from this sentences you have to draw this data. Now can you put in this formula, what is the answer here? What should I write? Probability of rain, so rain means this figure, cloud during sunrise means this figure, right? Rain given cloud in sunrise is probability of cloud in sunrise given rain. See, cloud in sunrise given rain. What is that? 50%, 0.5 into probability of rain as per the formula, guys, right? Probability of rain, it already given it to you, 0.25 divided by probability of what? Cloud at sunrise. This is also given to you. What is that? 0.15. Now whatever calculation you will do from here, that is the answer of your this question. Probability of rain given CSR. Okay, we'll solve questions on this. Okay, real questions that you are, the similar kind of questions you are going to get any interviews. I have also faced the same. I'm not sure about recent days, but yeah, before
What question you got? Just like my network
yeah, I
was
have.
rumbled.
Yeah, so those questions I've already provided to you, and we'll solve also one thing.
Okay, okay,
Okay, let's do one thing also. Let's try to solve one of them first.
okay,
So this is the folder I have already shared with you. Here you will find these 3 PDF: conditional probability PDF, naive Bayes PDF. So these are the questions with answer. Let's try to solve one of the questions. I'll give you 2 minutes. You go through the questions and the first question, and whatever we studied right now, you try to correlate with that. I know it will be a bit difficult initially, but yeah, and the more important thing is you have to practice with these questions. That's why I'm providing all these PDFs. Okay, so I have to spend some time. Now please go through this question. Okay, these questions, and try to solve it what we just learned using likelihood, prior, posterior, and that one. Take 2 minutes. I'm going on mute, guys. Okay.
but in here the whole the whole formula was different, right? Like as we
No, this is
see,
same. You just need to draw out. You just need to draw out the points or the posterior, likelihood. Okay, prior, these things you have to draw from this questions. Then you can.
okay,
So first of all, identify what probability given what you are calculating. That is the tough part. Okay.
okay, okay.
So guys, how is it going?
Really tough, sir.
So this type of questions, at least you expect 1 or 2 questions from this, because this kind of questions will give an impression on the recruiter that you have some conceptual, or you are not going to get confused so easily. Okay, this is what the proof is. So here you need to practice these questions. Like these are the PDF from where I practice, so just providing to you with answers, so that you first do yourself, then match with the answer. That's what you need to follow. Okay, so let's try to decode this. Okay, I'll try to help. Have you thought what you need to do? Anyone wants to give a try? What is given and what we need to calculate? Or first you tell me what we need to calculate. What is the question here in terms of that probability of A given B? Tell me, this is what we need to calculate, probability of this given this. Tell me that
Okay,
one.
so in my understanding, like there is a disease, and if we were taking a disease test, it was giving us the 91% of accurate result. Like if in the test positive result, like if the test was positive, then the disease rate was 99%. If it is negative, then it is also like negative 99% was there. Like there is a 1% of people, like in the question, like if 1% of people have a disease, you will feel positive. Oh God, just now I feel like, okay, I'm clear, but totally it's gone
Okay.
now.
Okay. Don't worry, guys. I'll try to help you as much as possible, so that you will get a at least few understanding in one go. At least you won't face my kind of situations. For days I was like, okay, what is happening? Okay, but yeah, I'll try to give you a best shot here. So see, you have to so in this kind of problem, you just understand the sentences, sentence by sentences, and maybe there is a chance few of the sentences, maybe they will give you to distract you, which is this first sentence, which is nothing going to do with our question actually. So the test is advertised as being 91% accurate. That means if you do the test 91% times, you will get accurate result. Rest 9 of the times you will get inaccurate result. Okay, this is one thing. Now second point, if you have the disease, you will test positive 99% of the time. So now here is the hidden part here, the evidence. What is the hidden evidence here? If you have the disease, that means this bar, right? Probability of something of given this bar, right? Right hand side to this bar is given here. If you have the disease, that means this is known. So for disease, I'm writing D. If you have the disease, you will test positive 99% of the time. That means probability of testing positive. This is what it is given. Probability of being positive when you have the disease is what?
99%.
Now here, can I say probability of being positive when don't have the disease? Don't have the disease, I am denoting D bar. Okay, what is the value?
0.01.
Yeah.
From
the
our
same.
first accepted truth, probability of this plus that equal to 1 if 2 events are occurring, 0.01. That means I can also classify it as a positive even if I don't have the disease 1% of the time. So these two details we extracted from which point? This one sentence. This sentence. This is what you need to do. You have to read the sentence and draw these things for you. Probability of being positive when you know you have the disease, 99%. Probability of being positive or tested positive when you don't have the disease, there is also possibility is 1% time. So why, like I'll make your life easier here. So if I'm going to calculate probability of being positive, that means this is event 1, this is event 2. And if I'll use total probability theorem, then what? Probability of this plus this, isn't it? If I'm calculating probability of being positive, not with evidence. Okay, now I'm going to erase this. Okay, guys, let's go to the next. And if you don't have the disease, you will test negative 99% of the time. Tell me what is given. Tell me probability of that this is 0.99. What I need to write in the left, what I need to write in the right. You tell me.
Negative left side and D
Negative
bar.
left hand side and
D bar.
D bar. Correct. Now you are getting right. Probability of being negative when you don't have the disease, 99% time. That means what? Probability of being negative when you have the disease. What is the chance?
0.01.
Making sense? If 99% of the time, if you don't have the disease, you will test negative. But there is 1% chance, if you are unlucky, you will get, you have the disease, but you will test it as negative. Now, this is a dangerous scenario, isn't it? You have the disease, but you are tested as negative. Okay, now if this is done, I'm going to erase this part also. Now, if 1% of all people have this disease and you feel positive, that means what is given, guys? Tell me. Probability of what given what is 0.01%. Probability of having disease when you feel positive. This is given, isn't it? Guys, you are getting from this sentence or not?
Yes, sir.
Tell me whether this analogy is correct or not. If 1% of all people have this disease and you feel positive, this is not the analogy here. Total people, from the total people, 1% of people have the disease, but you feel positive. This doesn't mean like probability of disease given positive is 0.0. This is totally different here. So be aware of this kind of things. Okay, don't go with the flow to write like this. Here it is saying 1% of all people have the disease. That is separate part, but you feel positive. That means this is something else. That means
Maybe negative also.
so here this is given to you. This part is not given here in this sentence. 1% of all people have this disease. That is nothing to do with you, right? That is a different thing. But you feel positive. What does that mean? Sorry, this is plus. You feel positive. That means you are being positive, that evidence is given. Now what you need to find? The probability that you actually have the disease. That means this you need to find. Probability of actually having the disease given you feel it is positive. This is the question that you are looking for according to the question here. What is the probability?
Actually, here they are not sure now that that person is positive. Maybe positive like that.
May not be positive. Yeah. That's why we are calculating probability, because probability means possibility. We are not sure. It may or may not happen.
So Ashish, this you feel positive they mentioned, no? That is about test, or it's not about test. That part is a bit confusing.
That means you are positive. That is given. The evidence is there. You are positive.
Okay.
That means In the right hand side bar, you have to write you are positive. So this evidence is given to you. You feel positive. That means you are sure you have positive. Now, what is the probability that you have the disease? That means what they're asking. Probability of having disease
Okay.
even you are positive. This is the answer they are looking for. Now tell me how to write the formula here. So what we require probability of having disease given positive, right? What is the formula here according to Bayes formula? Probability of being positive given I have the disease into probability of disease divided by probability of being positive. This is my question.
But in here, like there is a sentence for negative, right? Like we haven't considered negative till.
Where is the negative?
Like if you don't feel a disease, you will test negative 99% of the time, like that.
Yeah,
What
we
was
derived that data, right? If you, where is that? If you don't have the disease, you will
Yeah.
test negative 90% times. What does that mean? Probability of what?
D bar.
Negative.
Yeah.
Negative.
Yeah.
Test, see guys, three things: being positive this sign, negative this sign, having disease this, having not having
D
a
bar.
disease.
Yeah.
So here what in sentence? If you don't have the disease, you test negative. That means what? Probability of getting tested as negative given
Yeah. D bar.
you don't have the disease, right? So
Yeah.
four things: P plus minus D bar. These things we are using.
Okay. So if you don't have a disease, means like first we have to get the 99% as a negative, and then the D bar is the 0.1 is the value, right?
So this means probability of being negative or possibility of being or identified as negative given you don't have the disease is 0.99. This is what it in this sentence it is telling.
Okay.
I know, bit confusing because so many factors we are considering here: being positive, being negative, having the disease, don't having the disease. So many things we are doing, right? So it is very easy for any common man to get confused.
Okay, I think I have to go through the videos, like the
So
recording.
no, it's not
1,000 times,
done
I
yet,
think.
guys. It's not done yet, guys. You have to spend or you have to complete this whole PDF, doing your own and seeing the answers. And also, I'll tell you a few of the questions, the answers, variable name or the terminologies are not correct, that you can rectify if your understanding is proper. So here it won't come to you one go, guys. Please don't do that mistake. I already banged my head. So the only thing is to practice this type of questions. No alternative here. Practice this type of questions. Even if when I'm explaining this to you, batch by batch, my explanation is getting, purified. If I'll consider my fast explanation, like totally different. So that means practicing this kind of questions is making you understand the logic better.
Sure.
Okay, so that's why the PDFs contains so many questions with answers. Okay, please go through that. Now,
Oh, excuse me, sir. That first line, excuse me, sir. The first line they are given the disease test is advertised as being 91% accurate. How can we write or how can we get the lines?
Tell me about the first line. What they have done? What the probability of what they have given?
A disease probability
test
plus
the disease test, the probability of what? Test result.
Test accuracy, right, sir?
Sorry.
Okay.
Test result, probability of test result is accurate 91% of the time. This is the first sentence. And do this probability of test result filtering in our this question. Can we use this probability of test result? No, right? So that's why I told you. Sometimes they will give you that kind of data which will divert you from the main topic. Here our job is to find what? Probability
of having
disease when you feel positive or you tested positive. This is about the test result.
Yeah, that is the unwanted thing, I think so, though. So that I am
Correct.
asking you whether we have to
You're-
include it or not.
So your
I'm
analysis
just confusing.
correct. That's why. So always try to understand what you need and what was given to you. Here it is given probability of test result. Okay. So
Okay, sir.
now
Okay.
tell me what I need to put in this formula. What values? You tell me. Take a moment of pause, and what I am calculating, what I need to. So what I need, probability of being positive given I have the disease. This information I need, and probability of disease I need. Tell me what I need to put here. What is the value? And probability of being positive I need. To calculate what? Probability of having disease given you are positive. To calculate this, I need these three values. Tell me, what is the three values of probability of being positive given disease?
Being positive. 0.99 given 0.1.
Correct. Right. Correct. So if you have the disease, that means you have the disease, you test positive 99% of the time. That means what? 0.99. This one is 0.91. Correct. Probability of having disease?
0.001.
Why?
No.
No, sir.
No, you are correct. Tell me where you get that information. That answer is correct.
So 1 divided by 100. No?
1% of all people have this disease.
Yeah.
It is written here, right? 1% of all the people having disease. So that means probability of disease is 0.01.
0.1, yeah.
Probability of being positive, tell me, where can I find this value?
That we already can see, right? Like probability of being positive is 99% of all the time when we take a test.
When we have the disease, that is one clause. When you have the disease, probability of being positive is 99%. That's why when I explained this thing, I told total probability theorem, right? Break down this thing into events. What is event 1? Probability of being positive given you have the disease. Event 2 is probability of having disease given you don't have the, probability of being positive. So probability of being positive can be calculated from these two events. You tell me whether you agree or not.
Yeah.
Yes.
If you don't, yeah.
And this is same as our factory problem. Now this event 1 is factory 1, this event 2 is factory 2. And probability of having a positive given disease is this much. But we were multiplying something there while choosing the factory. What is that value?
It's selecting
Before
value.
0.5.
0.5, because that value we are choosing to select a particular event.
Yes.
Now,
So,
if I
yeah.
I
So
need to
50% chance there is a disease or not disease.
but that is specific to that factory problem. Here, what is the probability of getting this event 1? So here, I'll tell you what we're going to do.
So 1
Something
minus
into event 1 plus something into event 2. Remember, trying to recollect the factory problem. This is what we are doing, right? To calculate the total probability. Some factor, there it was 0.5 because we are choosing one of the factory, and this probability into this probability. So for event 1, probability of having disease you need to multiply, because you have to, the event is what? From you have the disease, you don't have the disease, right? What is the probability that you have the disease? That you need to multiply with event 1. This sum into event
1 into event 1.
Right. So probability of having disease is what? What is the factor? 0.01. Right? 0.01 into event 1. That is what? Probability of being positive given you have the disease. Plus, what I need to multiply again? Probability of not having the disease? 0.99.
0.99.
If probability of having disease 0.1, there what we are multiplying? 0.5 here, 0.5 here in factory case, because probability of picking from one factory is 0.5. Here probability of having disease we are multiplying. So this is, if this is 0.01, this is 1 minus 0.01, that is 0.99 into event 2, that is probability of being positive when you don't have the disease. Now this is your value of probability of being positive. If possible, I'll explain it again, no worries guys, but try to digest now. So once I have this data, then I can calculate, right? I'll put everything in the formula and I can get the answer. Shall I repeat this one?
Yes, sir.
Okay. First of all, I'm going to write the formula for you.
Excuse me, sir. Can we take it in other way? Like if a person is positive, it is 99%. So 1%, if the person is having disease.
Your voice is bit slow, Niveta.
If the person is having disease, it is 99%. So automatically, the person don't having the disease will be 1%. So it will be like 0.08.
Yes, that's how we're calculating, right? If 1% of people have the disease, that means 0.01. That means how many people don't have the disease? 0.99. Same thing you are saying.
Yes.
But I think my Zoom got crashed, guys. Just give me 1 minute. Are you able to see the screen movement I am doing?
Yes, sir.
Yes, Ashish.
No, sir.
Because it is already closed in my system. I am relaunching Zoom. If you have seen,
Yeah, now your screen was,
not there, right?
not there. Yeah.
Just like, so I'm connected through phone now. I'm talking through your phone. Let me relaunch. I'm not sure why that happened. Maybe the system also get confused with this conditional. This is called conditional
Maybe.
probability. Okay, so conditional probability.
Oh God,
is
how many probability I have to like total probability?
No, this much only, and this is the maximum level of question you are going to get, not more than this. Okay.
Okay.
So this is the maximum level. Zoom quit unexpectedly. Send report to Zoom. No, I don't want to send. Just get me back. Just 1 second, guys. Got it. We is having the host access, or I'll be able to.
Me.
Let it be. Let it be. I just need to share the screen. Can you see the screen?
It's loading now.
Okay, let me explain that again, guys. Okay, let me explain that again. Tell me what we have and what we need to calculate. First, tell me that probability of what we are calculating. What is the probability that you have the disease? Probability of disease I'm calculating, given that you feel positive. This is what I'm calculating, right? Now,
yes.
This needs what? Probability of being positive given you have the disease into probability of having disease divided by probability of being positive. Now, probability of being positive, I am expanding using total probability theorem. What is the event 1? When you have the disease, then also you can test it positive. When you don't have the disease also, then also you will test it positive, right? Two things. So when you have the disease, what is the probability of you having the disease? 1%.
Yeah.
That is 0.01 into probability.
When we feel positive, there is a chance of 1%, right?
Right. Plus another way of being positive, when you don't have the disease.
Yeah.
That means 0.99% you don't have the disease. If 1% you have the disease, into what? Probability of being positive given you don't have the disease. This is the total value of probability of being positive. Please try to understand this one. And here is the catch. This is same what we are doing in the factory one. But there the probability of individual event was 0.5. Here it was mentioned 1% and rest is 99%. Probability of having disease into probability of being positive having disease, given disease, plus probability of not having the disease into probability of being positive given you don't have the disease. In this two scenario, you can be tested as positive. Now tell me what I need to put here to calculate 0.01 into what is the value given in the data? You have the disease, you will test positive 99% of the time.
Yeah.
That means what?
0.99.
Probability 0.99
0.99.
plus
Yeah.
0.99 already here into probability of
Zero.
being positive given you don't have the disease. What is that?
0.01.
Yeah. Like if
And
you,
where you got that data? From this first sentence only, isn't it?
Yes, sir.
If you don't have the disease, then you have 1% of the chance that you being positive. That is 0.01. Now this is the value in the denominator, the whole thing. And what is the value in the numerator? Tell me. Probability of being positive given disease. Again, 0.99
0.99.
into probability of having disease 0.01
0.01.
divided by this whole thing. This is your answer. And I think let me verify. I'm going to erase this, guys. Let me verify from the answers is given in the PDF. If you see here, this is what we're calculating. This is for sure, right? And this is the formula. Probability of D given plus. That is probability of D into probability of plus given. So here T means they are referring as what is this? This is not T, this is actually D. Okay, so this kind of mistakes you are going to see, guys. Be careful there. So this is not a T, this is a D. Making sense? So just a little bit of modification here, but the rest of things is same. Can you see 1% into 99% according to our formula? Just let me undo. Okay, can you see in our numerator what we got? 1% into 99%, right? Same here, right? 0.99 into 0.01. In the denominator, what we got? 1% into 99%. That means 0.01 into 0.99 plus 0.99 into 0.01. Same thing we're getting. Can you observe here, right? Now here, little bit of modification. This T should be replaced with capital D. That's all. Okay, so like this you have, okay, it's 10:55. Oh God. So yes, so I think we have some request from Divya also to go to that question that we left yesterday, MongoDB, the last part. Have you guys tried?
Yes, sir. That last part
Okay.
we have not tried.
And, okay, so guys, let's not, I don't want to get you overburdened with this. Okay, so these are the questions with answers, similar kind of questions that you are going to get. Okay, and try to see whether any terms like this, okay, like some things are written here like it is not there, right? T. So D, that means wrongly they printed T. Okay, so those things also be careful while going through this, questions. Okay, so this is one PDF and two more PDFs are there with conditional probability questions, naive Bayes related questions. Okay, try to go through this. I have already uploaded this one. And let's not, going forth on this one, because like here a few of the conceptual part now, like almost done. Okay, PDF, CDF, and this some conceptual thing about difference between naive Bayes and Bayes theorem that we'll cover tomorrow. Okay, let's not burden ourselves. Okay, but before closing the session, please show me that that MongoDB last one to many reference. Have you implemented that? And if not, can you do it now by sharing your screen?
Yes, sir.
Do it.
Shall I share my screen?
Yeah. But your batch is going slowly but steadily, I can say. But yeah, obviously, like we are taking 1.5
Yes,
session
sir.
for
That
every.
when we go slowly, we can easily understand. That yesterday only I have tried all those things from the MongoDB start itself. I can able to do it myself, but at the last part we are going a little bit hurry, so I can't able to follow those things.
No worries, no worries, no worries. You do it here. So this is what? This is the filter, right?
Yes,
This is the
after
query.
this, yes. After this part, we have that reference 1 to 1 or 1 to many, I think so.
So open that file that I shared with you. Not from here. Here, yesterday's folder. Let's do it. Implement this one. I felt you guys. If you want to go slow, we'll go slow. Not a problem, because I can see you're starting from scratch.
That so reference 1 and many, actually you did it yesterday in your Jupyter notebook.
Okay, you do it once. Open that reference 1 to 1. 1 to many also you can open.
Yes.
So what you need to do, you have to create collections, 2 collections, and insert the details. Do it.
Okay. For that, I'll try to make a connection for this.
Yeah, sure. Yeah, go ahead. And guys, this is what we'll stop here. Those who want to learn this last concept of MongoDB, you can stay, and those who wants to leave for office, you can go. I'm not going to cover any new thing. Tomorrow we'll start. I hope this theoretical probability somehow you like read the
Actually,
books.
this is very tough, sir. Please take 1 or 2 days additionally, and please explain. Actually, when we learn from the outside or while reading those things, we are getting some concepts. Even though the very better thing is when you say, and when I hear from you, means it will be very better. It will deeply register
I
in
totally
my mind.
Agree. Totally agree with your points. So unless we have some noise from the management team, I am okay with it. Okay, I can go with you. I'm happy to go with you. Once you understand, then move forward. I am happy. But if some noise from the management side, why it is taking so long to complete, that is a different thing. We'll see, but that has not happened till now. You can,
if need, we will tell them also, sir. Actually, the things we should not go hurry. We have to understand, and we can able to do by ourselves. This is the important thing, I think so.
Totally agree with you guys. I don't have any problem. I think management is also having no problem, unless we'll take much time on one topic. Okay.
This theorem thing is like, I don't know why, like I'm in a half sleep now. I was like, okay, Dinesh, concentrate, but still I don't know, like,
so
why
these are the tests that whether you choose the right field for you or not. Okay, guys, consider these are the tests, because if you are switching to this field, you have to develop immense level of patience. That is must require thing. Like I used to sit for 4 to 5 hours without getting distracted. Single 4 to 5 hours time, and more specifically take breaks also. If you take breaks, this is making our mind fresh to observe this.
Yeah, sure, sir. When we go very fastly, we are feeling very low. Yesterday, I am feeling very low. You told me that you will have a project that things will not cover with these sessions, like the way you told. Now I'm getting scared how to do all those things. Do I can able to do that or not? Like the way I'm scared. After that, okay, let it be. We will face everything.
So
what will come,
correct.
will let me face.
That's what. That is the right approach. Don't fear. It will come, but don't fear. Face it. So that's why I told you, knowing Okay. So here, can you?
From our mistakes.
Correct.
Yeah.
And this is what machine is also doing, guys. So this artificial intelligence is actually subset of our intelligence. It's nothing new. People are fearing about ChatGPT will replace us.
Ashish, I think like because I'm a host now, like I've received a message from like Sumara. What is the project do we have, sir?
So you will get in mail. I'm totally not sure whether the same project that the previous batch is doing, you are going to get that one, but similar to that one, extracting details from YouTube, and using the API, you have to build the database, create an application, kind of that one, like from a
So
technical
for
domain.
all these, like for all these, like we have to reference the videos, we have to reference multiple documents, and then we have to do all those, right?
Yeah, so you refer whatever you want to refer, but you have to complete that project on your own,
Okay.
without like, even if you are copying some code from anywhere, you have to
Mhm.
explain line by line what is the code means. This is
Okay,
what
with
the
the documentation we'll give for a project if you were submitting.
correct.
Right.
So Divya, what you are doing? One second, Dinesh. Let's help Divya. He's struggling actually. This is Divya, like there you need to understand what is the data and what are the commands. Can anyone help Divya here if you got it? So we are going to create two tables, and what is the data and what is the,
I can't hear you, sir. Your voice is breaking.
is it right?
No, I think she has a issue.
Okay. So Divya, what you are doing, let's just explain to everyone so that we'll all be in
Yes,
one
sir.
page.
I am just creating a connection and connect with the database. I'm creating the collection name tables through the variable my column.
Great.
And this is the data. This is the data I have named as a data set. And I'm trying to insert the data in the collection.
Okay, great. You are doing great. But here you are doing some mistakes. Can anyone try to identify what mistakes he is doing? Go up.
Many. On where, like in the first one, right?
Yeah. So what is the mistake here he is doing? So actually, your data set, in your what is the variable to your data?
My column.
That part. That is the table, right? That is the collection name, right?
Yeah.
My column.
Yes.
What is the data that you are going to insert into this collection? What is the data?
Tables.
So select the data and
this data set. Yes, data set.
But this data set is like you are also including some additional things. That's why select me the data that you want to insert. Select in your cursor that this is the data that I want to insert, not that one. So this whole thing is not the correct answer.
Yeah.
Specific to the specific table I'm asking, like the first table. Consider the first collection that you want to create. You created a collection, right?
Yes.
My DB tables, right? And you give my column to that first table, right?
Yes.
Right. So how many tables we need to create here to understand this?
Actually, this all belongs to one table, right?
No, that's why you're confused, and that's why you're getting confused. Here, referencing means we are using two collections. Then only we'll refer one table to another, like join. So first of all, you create two collections. You only created one collection. Create another collection.
Here.
That is one collection, and that name is what? No, this is how you not create tables, right? Multiple tables. No.
Yes, sir.
No. You have to write that same line with other name. So this is one table. You have to create another table. Right? But the variable name you are making same. That is also
table one, then it'll be fine.
Actually, I already have created the table name, so that I just for the name itself I have given like that.
Hold on a second. Divya, just observe my cursor here. Okay. See, you have to create two tables or two collection inside your DB. Then query, you can join these two tables. Here, one
Huh.
table you created, another table you are creating, but giving the same name, right? So I want two
Okay,
tables,
okay.
right? So
Yeah, yeah.
do that.
Column 1. Yeah. Now I
Right.
got it, sir.
Got it? Now you clear?
Yeah.
This is first step.
Yes,
We'll go
yes.
step by step. First step is understood, right? Second step
Okay.
is these are empty tables or empty collection. Let's insert some data in each of this table. Okay.
Okay.
Don't do
Okay.
anything unless let me annotate for you.
Okay.
This is the data what I am selecting. Exclude the what?
Okay, okay.
This is the data for this table. Okay. And
Okay,
what?
sir.
This is the data for what?
For the
This
second
table.
tables 1. Huh.
Now you
Okay.
define this and insert the details in the respective table.
Shall I insert it?
So no, first you define the data. What I selected, you define
Okay.
or create variable and store there. Because what I selected, what I don't select, those are unnecessary parts.
Okay, okay. Data set this particular
Okay,
please.
so
This particular details is for the tables. One
so do one thing.
One
Do
collection.
No, do one thing. Mark my pen here. Okay, this is one table. This is one table. You define data one variable and you store this data. What I'm selecting here. You store this data in this data in this variable. Then data 2 you define again and store the below details.
Okay, here I can give the data 1, right?
And what you need to store there?
The tables.
Not tables, this data. So remove this parts, remove this parts.
Shall I remove this?
Yes. So
you are
again,
defining a
mark
variable
my
and
marker.
then like as we do.
Mark my marker here. Remove this part till this part. Okay.
Until many. I think you have removed the brackets too. Yeah, until many. So like you're creating a variable and then you're going to pass that variable into that insert many function.
Correct. Right.
Get it.
So you can remove this round bracket also, Divya. A round bracket from starting, from end.
Yeah, end.
Again, I'll summarize. You are creating empty tables. Now you are making your data set ready to be inserted into these tables. Making sense, Divya?
Okay. Yes, sir.
Now this is data 1. Another cell you define. So this is for table 1, right? This is table 1. This is table 2. This is for table 1. You are now your data is ready. You have not inserted yet. The data is ready to be inserted. Now similarly, you create data 2 for table 2.
Yes.
You need to define a variable for it.
Yes, he is doing that. Data 2. Okay. And which part you need to remove this from the query? Right. Right. Remove that one. So this is your data 2. Okay. Now insert this data 1 into table 1, data 2 into table 2. How to do that?
Yes, that through this method.
So you have to do it how many times?
One time. Insert 1.
Hold on. Again, I'll summarize. I think you are bit of confused. Again, I will summarize. 2 tables you are going to create. Table 1, table 2. Like you created in the above cell. Go to above cell. Table 1. So this is what is the name of this table? My column or collection. You don't use table for you only. I'm using table. It is collection. My column. This is what? My column 1. Blank collection, right?
Yes.
Now this data 1 you need to insert here. Data 2 you need to insert here. So how many actions you are going to perform?
Two.
Two insertion, right? So you have to write two insert many statement, right? One for this table, one for this table. Do that.
Yes, sir. For my column insert many, here I have to give data 1.
Right. Don't run that. Write another thing in another cell, another insert statement. Don't run that cell. We'll see. Correct. Now you are getting it. So my column is the name of first table or first collection, my column on the second. And here also insert. So if you see insert many also will work, insert one will also work, because data 2 is only how many documents?
One.
Only one document. So use insert many, not a problem. Here what you need to pass? Data 2, right? Now you are clear?
Yes,
So
sir.
in
Yes, sir.
this way, we are creating two tables. We are storing the data over there. Now run the first cell.
I think the camel case.
Data is not defined. You have not ran that cell actually. That's why it is not getting stored. So here, do one thing. Don't run it, or you'll get again error, because other codes are also you are writing below that, right? So this cut paste this data 1 and data 2 in a different cell. Cut paste. Till this one, yeah. Cut paste. Control X.
Copy.
Control X. Control X. You do Control X. Go to it. Create a new cell above to that. New below to this cell number 2. Yeah. Here. Paste it. Control V. Okay. Now you run it.
Invalid syntax line.
Remove those stars. Remove those stars.
Yeah.
Or do one thing. Don't remove. Give a hashtag in the beginning. Now run. ID. And yeah, you remember these things need to be inside this quotation, right?
Yeah.
Data 1. Go to data 1. Yeah. Make these are quotations. So select the whole world and only type quotation. Don't go for beginning and end.
Yeah, like you need to double click on the word and then
double click on the word. So double click on that word. Yeah, press the quotation now. Okay.
Yeah.
Got it, Divya?
Yeah,
Right.
yes.
And also this ISO date you remove. This one specifically for inside MongoDB. Just keep that date. Remove that ISO and all that brackets and all. Remove
that
that.
ISO is something like we were giving in the
Environment
JSON, right?
specific. Yeah, if you write this code in directly MongoDB database, then this will work. But
That
as we are
ISO
doing this, as we are doing this in Jupyter Notebook, no. So this will tell you the error. What is ISO date?
Oh.
So let's make it simple. Just keep it in a string format. Now can you run this?
Yeah,
name-
here I have to.
Yeah, correct,
Yeah,
correct.
change it.
Do it. Do it.
Yes, now it's okay.
Yeah. Run
Shall I
this.
run?
Yeah, run. What is that?
There is a error again.
Go unhashable type.
Unshapable.
Unhashable type list.
Yeah.
Just a minute. Here, what you need to give, you give that in a quotation.
Where,
That's
sir?
project IDs. Project IDs, not here. Project IDs, what you have written in the right hand side, give that in a quotation.
That I remove the curly braces.
No, keep that curly braces. Okay. Now can you run this?
Data 1 is not found.
No, that is different.
Defined.
That ran successfully.
Mhm.
That ran the code ran successfully. Now run this one.
Maybe I have the data 1 already have created the one data. Maybe I don't think
No,
so.
I think that's the first time you ran. Na? That
See,
time
guys,
the error was came.
See guys, your understanding is bit wrong here. The cell executed successfully. There is no error you face.
Yeah.
Okay, the error you are seeing below to this cell which you ran previously.
Yeah, initially, yeah.
Initial error.
Okay.
This is different. Okay, so don't get confused like this.
And also, Ashish, like the project ID she was given in the quotations, right? So if we need to access the list, then do we able to do it actually, because it's inside the quotations, right?
Yeah, so we are passing this as a string. We'll see, because if
Mhm.
you don't give the quotation, so either you need to do with this. Just 1 second, Divya. Let me verify with my system, my code that I have written, whether to just 1 second. Okay, let me
Okay,
verify.
okay, sir.
Be over there. Let's see whether we need to use the quotation or not. First of all, let me start the MongoDB. Just 1 minute. Yeah, Dinesh, you are saying something.
Yeah. So because with a list, instead of list, we were using it as a string, right? So if we want to perform any operations on it, then it won't help us, right? Because the string will not have that aggregation stuff.
Correct. So just to verify that, let me just open my Jupyter notebook and see the code from there. What I have used, so that we can save some time, or else we'll get unnecessary errors and our head will bang our head. Okay, so just 1 minute. Let me. It's opening the Jupyter notebook I have launched. It's opening. Okay. Just a minute, guys. Where I have the file, MongoDB session, MongoDB. Let me check, guys. 1 second. Okay, this one, insert data. Guys, just 1 minute. Okay, I'm still not able to find the code. Where is it? MongoDB, this one. Why it is taking so long? Yeah, it came. Just where is the data?
Have you uploaded that in the G Drive, Ashish?
No, this file I have not uploaded. This
Okay.
IPython notebook I have not uploaded. The text containing that query or the syntax I have uploaded. Let me just quickly verify what we are passing this as. I got it. Reference details here. Okay. I have not implemented the second part here. That is the multiple ID. But here, how we are passing this? Mail personal details ID. Okay, can you give? Okay, the second part I have not implemented actually. Can we try to implement the first part first, like one-to-one reference? Divya, let's not go for second part first. But
Okay,
I'm
sir.
when like one-to-one reference. So what you did, you just need to modify bit one. Hold on. So here, I think you are not, unless I am confirming, like I need to implement this in my system first. Let me do it, okay?
Okay,
Let
sir.
me do it, then we can, or else we'll unnecessarily get errors and this will waste our time. Let's do one thing. I'll do
Okay.
one thing. I will create the scripts for you separately again.
Okay.
Okay, and I will share this with you tomorrow. Let me give that time, because this one to many I have not explained in my notebook. So I'm not
Okay,
sure.
sir. Okay.
So, but yeah,
And-
1 to 1 you can do. 1 to 1 I have already did it.
Okay, sir.
So 1 to 1 you try to do. Do you need to, do you want to explore this 1 to 1?
Yes, sir. Actually, that the data that yesterday you have explained in the Jupyter notebook, we don't have that book itself in the G drive. So that I don't know how to do and what to do like the way. So that I am asking you.
So do one thing, implement 1 to 1 first. Let's not go to 1 to many. 1 to many, let me check and verify. You implement 1 to 1 first. So to implement 1 to 1 first, name, you didn't run anything, right? Okay, hold on a second. Go to the text file. 1 to 1 text file. This is 1 to many. I'll just tell you this 1 to many tomorrow. Okay, 1 to 1 let's try to implement today.
Okay,
Here,
okay, sir.
copy the data for table 1 and copy the data for table 2. Do one thing.
Shall I copy it?
Just copy the data. Don't copy that dv dot reference personal details. So only copy the data. Like after the brackets. After the round bracket, you copy everything. Not that is, copy the only table 1 data. Divya, copy only table 1 data. What is table 1 data?
Is it enough? Is it enough, sir?
Is it enough? But after you paste it, remove the square, round bracket.
Okay.
Copy it, and
Yes,
go
sir.
to your
Copy
data one, paste it.
Shall I remove this and paste it?
Yeah. Remove everything. So this is for 1 to many. 1 to many we will see tomorrow. Let's first execute 1 to 1 first today. Data 1, then this part, paste it, remove the round brackets. Right. Now, the starting also remove. Now data 2, again you copy from that text pad. Data 2, right. Correct. Now data 2 also you do that. So this 1 to many I'll tell you tomorrow. Let's not do it today. Let's complete. Remove. Correct. Now you run this cell again. Okay. Now you run the next cell.
This one.
This one you run. Hold on. What is the error? Documents must be in non-empty. Okay. Sorry. So what you need to do? Go up. Use insert one. Instead of insert many. No. In the down. Where you are inserted many, right? Instead of insert many, can you use insert one? My column dot insert one.
Sir.
Right. Now can you run the cell? Okay.
Yes.
Okay. Do same insert one for data 2. Correct. Now run it. My column 1 is not defined because you have not ran that cell. What you didn't run? Go up. This cell you didn't run. Do it. Now you come there and run it again. Now
yes,
it's working. Right now verify the results from both the table. Import pprint. Right. Import preprint. Right. For IE in my column. My column is your name.
Yes.
My column dot find, then method.
Fine.
Then column enter preprint dot preprint I. Great. Now run this. Okay. Do it same thing. Do it same thing for another table. just copy the code, paste in the below cell, change my column to my column 1. That's all. Right? Okay. Now you run it. This is the
Yes.
second table. Now tell me what we are doing after all this drama. Like, what is our aim here? You have to join this table, 2 tables, isn't it?
Yes, sir.
Which 2 tables? This is the data, the table that you are printing the result. That those are the 2 collection. The printing
Yes,
using preprint, you printed
Yes.
the table results, right? Copy this
Yes,
code.
sir.
Copy this code. So this is to link to or to reference 2 things, 2 tables. Now tell me what you need to write here.
That we have to
Or-
join these tables.
Hold on a second. I will provide you the query for this one. Is that? Can you, okay, who is the host now? Okay, me. Just a minute. Make host. Hold on a second. Just a minute. I'm pinging one. Okay, you are not able to copy this, is it?
Yes, sir.
Can you see what I have pinged?
Yes, message I have got.
You have to write in this way.
Can I copy this?
I don't think you will be able to copy.
Yes, I can copy it and I'm just paste it in the new cell.
Paste it in a new cell. You did paste it in a new cell?
Yeah, yes, sir.
No, I can see the pipeline. The same. This is the copy from the chat, paste in a new cell.
Yes, that's what I have did.
No, paste in another new cell. Again, you do that.
Okay.
But I can't see your screen moving.
My screen is sharing only.
Can you do this? Reshare it again. I can see a frozen screen here. Yeah, now I can see. Yeah. See, this is not what you are copying. If you compare what you are pasting and what is in the chart, it is different, isn't it? See it properly. So that means from the chart you won't be able to copy. But what you can do,
from the chat itself I have copied it, sir.
Yeah, but it is not the value that is in the chart. You are pressing Ctrl C, but that is not working. This is the chart you pasted from the text pad, not from whatever you are seeing in the chart. So what I will do, just give me just 1 minute, Divya.
Okay, sir.
MOM copy, rename to code. Just give me 1 second. I'm giving you the code in a text pad so that you will be able to copy from there. 27th June. 1 second. Don't worry. I'll copy the code. You can access from there.
Okay, sir.
Just a minute. Okay. Here. Okay, got it. I am going to ping in the chat. Just a minute. Okay, can you see a notepad in the chat which name is code.txt?
Yes. Yes, sir.
Yeah, now download that text file and open it and copy the code from there. You downloaded, right? That? Huh.
Yeah, I have Try this.
Save it, huh?
Yeah,
Download.
I have downloaded.
Go to download code, huh? Correct. Now, if you'll open that text file, yeah, copy this whole code. Now this is the code to do one-to-one reference. Copy this to your Jupyter notebook cell. Okay, and try to understand what this code is doing. Try to understand
Yes,
that.
sir.
We are creating a
From-
pipeline which contains lookup operator. We saw yesterday, right? We understood about lookup operator, where it will say from local field, foreign field. Now recollect our yesterday session and tell me which table name I should keep here in the from, which table name you need to keep in the local field and foreign field. So our ultimate aim is to do
that
what?
from joining.
Joining to collection. One
yes,
from
sir.
is collection name one, local field will be collection name. So from means what? So if you see here, forget about the pipeline. Come next to the pipeline. What is next to the pipeline? Result.
That's from
Result, right? In the result,
yes.
First part dot aggregate is what? Table or collection name dot aggregate. Okay.
Yes,
now
the pipeline we are getting here.
So personal reference refer user is the table name or the collection name that I used. What you used instead of refer user?
Refer used is the data one.
So one collection contains the data one contains personal details. Another collection contains what? User details. So we are we need to use the user table or user collection. What is the collection which contains user details, not the personal details? As per your
data
code. No, that is variable. But that table collection name. Here we are using collection.
Column one.
Right. So which table contain user details, not the personal details? Verify it.
Yes. Data one is
two.
having a and the two is the
user details. Data one is the personal details, data two is the user details. So data two is being used in which table? That table we need to copy and paste there. Which table? Table name
user.
Which?
Table two is the user table.
What is the table two name?
Sorry, data two. Data two.
Data two is the data inside table two, isn't it? Data
yes,
two is the data inside the table. What is the table name? You tell me the table name.
That tables one have given that this one.
Right. Copy that variable name that is inside database. What is the name inside your Jupyter
My
notebook?
column. My column one.
My column one. Yeah. So copy that one.
Yes, sir.
And replace with what?
User details.
No, not there. In the result part. So result equal to table name dot aggregate, right? Table name you copied, table name you paste there. Ref user is table name in my system, not in your system. In your system, that table name is what? That just now you copied.
My column one.
Yeah. So replace that reference user table with your table name. Correct. Now this is my column one. Dot aggregate pipeline. Now the field which is specific to this table, that is called your local field, which is common.
Yes, sir.
And what is the common field in this local table? If you go to this
username, personal ID, password ID.
So this table contains user detail, personal details, right?
Ha.
Which key is the foreign key in this table, in this two table? Which key is
Foreign
the,
key is the ID name.
okay.
That 1, 2, 3, 4, 5.
Okay, so okay, Divya, let's not get confused. Table 1, whenever I'll say table 1, you need to refer user table. When I say table 2, you need to refer personal details table.
Okay.
Okay, we are on same page. Table 1 means user table, table 2 means personal details table. Now go
Okay,
to table 2 and tell me, table 2, go
personal
to
details. Personal details.
what is the ID there?
54321.
Right. And now go to table 1, which is
Ha.
containing what? User details. Now what is the ID there?
1, 2, 3, 4, 5.
Okay. But in that table, another field which is called foreign key, which is your personal detail ID. Can you verify that one?
Ah, yes, 54321 here.
That one and the table 2 ID one is same actually. And using this two, we are referencing it or joining it.
Okay.
Okay. So that means from which table, if you see from, we are giving personal details table. If you see the pipeline, where written pipeline equal to, then why this is getting opened up?
Actually, while moving cursor, it's pop-up, sir.
Okay, okay. In the pipeline, if you go to the code for pipeline, in the lookup operator, we are using from. In the from, where what table name we are giving?
Personal details.
Table. Remove that with your table name, which contains personal details. Yeah. Think. Don't worry. Don't worry. Just think.
Tables. Yes, yes. Tables 1, I think so.
Always remember you are doing it in what? Where? Jupyter Notebook. So the table name should be according to the Jupyter Notebook, not inside.
Yeah, my column 1. Yes, yes.
Yeah. So don't get confused. Try to digest this part. Okay.
The table means that actually
inside the MongoDB. Inside MongoDB. Okay.
Okay. Okay, sir. Okay.
But we are not writing all these things in MongoDB, right? We in Jupyter Notebook. So personal details table, my column or my column 1?
My column 1, personal
Verify
details.
that one. Verify that one. Which of your contains personal details?
My column is having personal details.
Right.
And one is having
user details. Right. Now local field means my column 1 here. Local field means my, no, don't remove that. The table is my column 1, but the field is that, can you see in your my column 1 table, you have a field called personal details ID. Can you see? Verify. In my column 1, here, stop here. My column 1, can you see there is a column called, it is not my column 1. My column 1 is below. This is my column.
Yes, sir.
My column 1, there is a personal details ID, right?
So
yes,
this sir.
One you are joining. That means that line you need not to change. Keep it that like that. Go below. Personal details ID is the foreign field. Local field. Foreign field is my column 1. My column's ID field, which is there, right? As personal details.
Yes, sir.
Can you run now this code?
This code. Yeah. ID 1, 2, 3, 4, 5. Password. Personal details.
Still, it is not collecting all the things. ID. Just a minute. Personal details is still, it is not giving you the proper answer. Hold on a second. Array of user, array of personal details. So personal details is in the from. Which table contains personal details, Divya, in your case? What is the name of that collection or table?
Column, my column.
My column or my column 1?
My column is, this is my column. This is the personal details. Date of birth, gender, first name, last name.
Okay, just 1 minute. ID,
User
ID, aggregate pipeline. What is wrong? It is like same we are doing, right? Something is wrong, which is not fetching the data properly. My column 1 is the user details, right?
Yes, sir.
Can you go below what we're writing? My column 1 or 2? Go below. Go below that cell. My column 1, right? My column 1 aggregate. Correct. Then pipeline lookup from, this will be personal details. Personal details is my column, right?
Yes, sir. My column is personal details. My column 1 is the user details.
Foreign details as personal details. Document result. Just 1 minute. Why I'm not getting the details here? 1 my DB. Hold on a second. Lookup from personal details, ID, password, first name, last name, DOB. Okay. Reference user, foreign ID, users table foreign ID will be same as personal details. Code. 1 second, guys. 1 second. Users personal details ID is the foreign key of ID table. So Divya, can you confirm personal details table contains ID, first name, last name, date of birth, gender in your personal details table?
Yes, sir. That first name, gender, last name, date of birth, ID is the personal table.
Personal details table, and that table name is, you are giving
5-4 column. Yes, column, and another table is column 1.
Another table you have ID, username,
ID, password, personal details ID.
Personal details ID. Okay. Now come to the result part. What you have written in the result part, in the result line, right? Below the pipeline.
That column yes,
1,
sir. Column 1.
Which contains?
That user details.
User details. That means ID,
password, username.
Okay. Okay. And aggregate, then pipeline we are passing. In the pipeline,
yes, sir.
From is our personal details. So personal details table in your case is
my column.
My column, right? My column 1 is
yes, sir.
Your user table. Please verify what I'm saying.
Details.
My column 1 is your user.
Yes, sir.
Personal is column, my column. Local field.
Yes,
local
sir.
field means from user table, you are using the field personal details ID.
My column 1.
Okay.
This one.
From the user table, you are using a ID, a field called personal details ID. That should be in your local field.
Local field means that ID is the same in
the pipeline. In the pipeline, you have mentioned local field, isn't it? What is
yes,
that
sir.
local field? Local field means my column 1's personal detail ID. My column 1, go to my column 1. and verify we have
Yes, sir.
personal detail ID, right?
Yes, sir.
Same thing we have created here also. Okay, go below, go below. Now this is okay. This is okay. Foreign field is the ID column of what? Of my column, only my column. What is, go to my column data and see what is ID there. My column, go up. ID is 54321, 54321, 54321. Okay, okay. Come down, come down. This is so far, this is good. This is good. Aaj personal details. But here, why it is not storing? Hold on a second, guys. Hold on a second. From my column, local field is this column. Foreign ID is ID. Run that again. Run that cell again. Why it is not showing you the right result? Can you see it is not the right result? Because in the personal details, it is not fetching the personal details thing actually. Personal details 1 2 3 4 5 password. Just a minute. Something we're doing wrong here. I'm not sure what we're doing wrong here. Let me identify. Okay, Divya, do one thing. Let's not bang our head. Let's continue this tomorrow. Okay, I think it's too much time.
Okay, sir. Okay.
Also, one other things to do. Can you do one thing? Can you copy this code from the table name to the insert?
This code.
Not this one. Will evolve to this also. Evolve to these cells also. From this data to evolve to that part. Data
Yes.
one. Data. Copy this thing in a notepad. And ping me in the chat. I'll need to do it. So I'll do it today. Or what I'll do, I'll create a fresh new notes for you on this topic, so that
Okay,
it will
sir.
want to. So create a text pad, notepad, paste these things,
Yes,
and
sir.
above to this also you have given the name, right? That part also. Go up, go up. Go up, go up, go up.
This
Yeah,
thing.
this part, this part. Give me this part. Let me see why it is, whether it is working in my system or not. Copy before this one, before this data.
That pipeline things.
And then also that pipeline things. Below, don't save it. Don't paste the whole thing, then save it. Go
Yes,
to
sir.
the
I have.
pipeline. Go to the pipeline code in your Jupyter notebook. Copy the code from there in the Jupyter notebook. Not this one, not this one. Go below. Go below. Yeah, this one. Yeah. Copy this one. And paste in that. Then you save it. Paste it. Okay. Now save it and share in chat.
How do I share this, sir?
Save it in your system first. And identify the location where you have saved. Name, what is the name you are giving? Data 1. Save it. Okay. Now go to the chat and share this file by uploading this in the chat. Let me see, because the same thing is working in my system. I'm not sure what is wrong here. I need some time actually. First of all, I need some break now.
Okay, sure, sir.
Then I will, yeah.
Actually, the same thing. Actually, I felt I don't know about the others. SQL we have finished that last time we have seen the constant and if else condition in that topic. That time also we have forget to complete that add that constant variables.
Now that time
when
I told you that you can't implement that in using SQLite. Unless
Okay,
you
okay.
install a
Ah.
database, you can't implement that because that is not there in SQLite to define the constant variable. That's why you have seen some error also there in the cell. I have shown you.
Yes, sir.
If you run that, you will get error. So
Actually, add link I have given, but that tab is not opened.
no worries, no worries. Have you saved this with me in the chat?
Yes, sir. I have saved.
No, not saved. Share this in chat with me.
No. Actually, I am trying to share in chat. That add link I have.
Not able to find. So can you see in the top left there is a emoji? Then right to this there is what? File, right? Click on that file. Okay, it will show you the option to upload from your system.
Yes, sir. I have tried that uploading a link, add link, link is there. When I try to link that, it's not opened.
No, don't go for link. Go for file option. Click on file option. Once you click on the file option, it will show you the folder to or the file to load from your system.
There
It's
is
not
no
showing.
file option here, sir. That emoji option is there.
Right to that, what is there? Right to the emoji option, what option is there?
Have you? Are you able to view my screen?
No, the chat I think we won't be able to view. So can you type a text to me like this? Can you type any text to me?
Yes, sir. Ashish Pole is not in this meeting like the way it shows.
No, I am typing chat. Are you getting?
Yes, sir. Yes, sir.
There, can you type?
Yes,
something?
Ashish, we can see the chat.
Yeah, can you reply back in that and verify you are able to connect or ping to me?
When I try to reply you, it shows the error. Ashish Pole is not in the meeting like the way.
What? I'm in the meeting only, right? Okay.
Actually, I am. Sir.
So you can't able to ping anything in the chat to anyone.
Yes, sir.
Kiran is able to ping me. Athira is also able to ping me. So, but why you
It's
are not
better
able
she logs off and logs in the Zoom again. Yeah, that's the only thing.
So, are you not getting this messages, Divya? Or do one thing.
Yes, sir. I am getting messages from you.
See. Do one thing. Let's not waste time. I am pinging my email address. Okay.
Okay, sir.
You send the file there. Okay, I'll check.
Okay, sure, sir. Sure, sir. Sure.
Okay.
Thank you. I'll send it to you. Yeah. Thank you, sir.
So attach that text pad and send the mail to me. I'll go.
Yeah.
on tomorrow.
Okay, sir. Thank you.
We'll see. Yeah. Okay, guys. Okay.
Thank you, sir.
We'll see. Yeah. No worries. See you tomorrow, guys. Yeah.
Okay, thank you.
Thank you, sir. Thank you.
Bye.